Good day. I'm Larilyn Maligdong, a BLIS student from NUNESCOS. Here I am today to discuss about the survey research and sampling. Survey research, the word survey literally means to look at or to see over or beyond or. In other words, to observe. Observations made during the course of a survey are not limited to those of the physical type. Major differences between survey research and other methods. Some argue that historical research, at least at present, is less bound to the scientific method of inquiry. Survey research is used to gather contemporary data, while historical research is primarily concerned with past data. Also, survey research is considered to be more appropriate for studying personal factors and for exploratory analysis of relationships. Types of survey studies. In selecting a research method, the researcher must keep in mind that research problem, the sources of the desired information, and the nature of the data to be collected. For example, if the purpose of the study is to formulate a problem for more precise investigations or to develop formal hypotheses, then an exploratory or exploratory type survey may well be in order. Exploratory surveys, it can be used to establish priorities for future research, identify new problems, and gather information with potential medical or scientific application, although results cannot always be anticipated. Specific kinds of exploratory research surveys include literature surveys or reviews frequently develop hypotheses that suggest the further research. Second is experience survey, the exploratory surveys that gathered and synthesized the experience or specialists and or practitioners in a particular field. Last is analysis of insight stimulating. Researchers have found the intensive study of selected examples to be useful methods of stimulating insights and suggesting hypotheses for future research. Analytical and descriptive surveys. The term analytical survey refers to data that are quantitative but need statistical assistance to exact their meaning. Other types of surveys. Cross-sectional study, a typical survey such as a Gallup poll designed to measure one or more phenomena across a sample representative of the populations or whole. Trend study, a survey conducted over a period of time so as to measure trends, patterns, or changes. Cohort study, a survey conducted in order to collect data from the same population more than once. Panel study, a survey designed to collect data from the same sample of subjects, often over time. Approximations of a longitudinal study, an attempt to stimulate a through. Parallel sample study, a survey of separate samples regarding to the same research problem. Contextual study, a survey of a person's environment conducted so as to learn more about the person. Sociometric study, a comprehensive survey of more than one group, including the interrelationships among the groups. Critical incident study, an in-depth examination of a specific event or activity rather than a broad survey of many occurrences. Basic purposes of descriptive surveys. Descriptive surveys can be used to describe characteristics of the populations of interest, estimate proportions in the populations, make specific predictions, and test associational relationships. Basic steps of survey research. Formulating objectives. When designing a scientific study, it is important to consider whether the method chosen is precise enough to ensure that the data collected will be relevant to the question or problem under study. Selecting data collection techniques. Selecting the method, for example, survey, historical, or experimental, is the first step in designing the specific techniques to be used. Selecting the sample. The selection of the sample is necessary step for a survey based on portion of a population. Finding based on a sample should provide a reasonably accurate representation of the state of affairs in the total group, and considerable attention must be given to the sampling technique for most purposes. Collecting the data. Survey research and sampling in the techniques of the data collection. Cleaning the data can involve everything from simply reading the result to verifying or checking the coding of the data. Analyzing and interpreting the result. It is useful to be systematic in describing the treatment of the data. The researcher should state clearly and specifically what data are needed to resolve the problem. It is also important to provide safeguard against error, such as checking the reliability of coders and statistical analysis. Survey research designs. The best that survey research can demonstrate is correlated. The independent variable X could represent age, and the dependent variable O could represent library use. A common design for survey research is known as the static group comparison. Survey research cost. Survey research tends to be relatively inexpensive, at least if the example or population being surveyed is not large, but it is still often desirable to reduce the cost. Recommended guidelines for reducing survey costs include the following: shorten the length of data collection, reduce the number of follow-ups, limit pilot or pretesting to a small number of participants, shorten time spent developing data collection instrument by adapting already existing instruments, make the instrument as short as possible, use non-monetary incentives to encourage respondents, minimize staff cost, shop around for less expensive supplies and equipment, reduce the number of survey activities, and minimize the amount of time each activity takes. Sampling. Rigorous sampling methods have been developed and used primarily within the context of survey research. Many of the specific techniques of sampling are equally applicable to other research methods used as content analysis, experimentation, and even field research. Basic terms and concepts. Before considering some standard techniques of sampling, it is important to have an understanding of the following basic terms and concepts related to sampling. First is the universe, the theoretical aggregations of all units or elements that apply to a particular survey. Like for the example, if one were surveying librarians, the study universe would include all librarians regardless of type, location, and so on. Population, the total of all cases that conform to a pre-specific criterion or a set of criteria. It is more specific or better defined than a universe and is in effect or designated part of a universe. For example, American academic librarians would be part of the universe of librarians and could represent the populations of a survey study. Population stratum, a subdivision of populations based on one or more specification or characteristics. Element, the individual member or unit of a population. Each academic librarian would be an element of the population of academic librarians. The total number of elements of a population is usually designated by N. Census, a count or survey of all the elements of a population, determination of the distribution of their characteristics. A complete census is usually not possible, or at least is impractical and unnecessary, so typically a sample of the population rather than the entire population is surveyed. Sample, a selection of units from the total population to be studied. It is usually drawn because it is less costly and time-consuming to than the population, or it may impossible to survey the problem. Case, an individual member of the sample. The number of cases in a sample is usually designated by lowercase n. Sampling, frame, the actual list of units from which the sample or some part of the sample is selected. It is often used interchangeably with population list. Types of sampling methods. It is useful to distinguish between two basic types of sampling methods: probability sampling and non-probability sampling. Probability sampling is the more scientific and useful of the two methods, and the bulk of this section will be devoted to that technique. Non-probability sampling will be considered first. Non-probability sampling. With a non-probability sample, the researcher cannot state the probability of a specific element of a population being included in the sample. Therefore, one cannot generalize from the sample to the population. Different kinds of non-probability samples that follow. Accidental sample. If one wishes to conduct an academic library user study, one might survey library patrons as they enter or exit the library on a first-come, first-served basis. Quota sample. Quota sampling is often used for public opinion surveys. Snowball sample. The snowball sampling technique is a type of non-probability sampling that allows researchers to follow up on the results of interviews with other members of the population. Purposive sample. There is no assurance that a purposive sample is actually representative of the total population. Self-selected sample. A self-selected sample is a group of cases, usually people who have chosen themselves for inclusion in a study. Incomplete sample. An incomplete sample is one drawn from an incomplete population list, even though it may have been selected randomly. Probability sampling. The purpose of sampling is to select elements of a population that accurately represent the total population from which the elements came. Simple random sample. Simple random sampling gives each element in a population an equal chance of being included in the sample. It also makes the selection of every possible combination of elements equally. Selecting the simple random sample. There are several techniques available for selecting a simple random sample. Traditional methods include the roulette wheel or lottery type approach. Such methods have been criticized as potentially biased or not fully random because of physical or logical imperfections. Systematic sample. Systematic sampling involves taking every nth element from a list until the total list has been sampled. Not every combination of elements has an equal chance of being drawn. Systematic sampling is generally as satisfactory as simple, random sampling, but only if the population list exhibits no trends or patterns. Stratified random sample. In selecting a stratified random sample, one must first divide all of the population elements into groups or categories and then draw independent random samples from each group or stratum. This technique reduces the number of cases needed to achieve a given degree of accuracy or representatives. Cluster sample. Cluster sampling involves dividing a population into groups and then drawing a sample of those groups. In using cluster sampling, it is desirable that each cluster's units be as heterogeneous as possible. This is particularly important if all members of each selected cluster must be included in the final sample. Determining the sample size. Bobby states that probability samples of less than 100 are not likely to be very representative of the population. There are at least 4 general criteria that can help to determine the necessary sample size. Samples that are quite small place significant impact on the data analysis. Use of formulas. Statistical formulas have been developed for calculating appropriate sample sizes. They take into account the confidence level, which relates to the probability of the findings being due to chance rather than represent a real difference. Sampling error. This standard error for the sampling distribution is the average of the means of an infinite number of samples drawn from a population. For example, if a population consisted of 50 libraries with each averaging 500,000 volumes, one should be able to draw all possible sample combination of these libraries and average their means. Other causes of sampling error. Bias is particularly a problem with non-random samples, as there is less of a safeguard against personal attitudes, preferences, and so on affecting the researcher's selection of cases. A researcher might be inclined, even unconsciously, to slight person who appeared to be unskilled library user or were sloppily dressed. Non-sampling error. People may lie about their age or report figures inaccurately for a variety of reasons, and the larger sample size possible is not necessarily the best. Non-sampling error is difficult to estimate, but generally, a sample size goes up, so do non-sampling errors. And for the summary, survey research is weak on internal control or validity, but strong in external validity. Survey research generally concerns itself with naturally occurring variables in natural settings. The only reliable way to ensure that the result of survey research can be generalized from a sample is to draw a representative sample.